Okay, that was the ending of the song Rain Song. Beautiful ending. Okay, so what we're going to do is look at higher order derivatives. And we've already talked about second derivative, but we haven't really gone much beyond that. So basically the notational system for this is f prime is the first derivative, Leibniz is dy over dx. F double prime of x, Leibniz is d2y over dx2. So the 2 just represents the second derivative. And then similar, if you have a third derivative, we use 3 primes, d3y over dx3. And then when we get past a third derivative, we just write it like this. So if you had a seventh derivative, you would just say f7 of x. Now, you may wonder, what in the world do we use higher order derivatives for? Well, in a Calculus 2 class, where you'll begin to learn about infinite series, you'll learn about something called Taylor polynomials. And the idea is this is something that can be used to estimate things like a square root to many decimal places, pi to many decimal places, and so forth. So higher order derivatives are used in that regard for estimating further and further decimal points into radicals, logarithms, all kinds of irrational numbers. So that's something that you'll see. Okay, what we're going to be working on this mainly is just crunching out some higher order derivatives. So first of all, on this one, we're asked to find the third derivative in Leibniz notation. So I'm just going to write this in Leibniz notation. So the first derivative is going to go like this. 2 is a constant. The derivative of sine we learned is cosine. So your first derivative would be 2 cosine t. Okay, then we move on to the second derivative. So we represent this as d2y dt2, like that. Okay, again, we have a constant. Bring the constant down. And we learned that the derivative of a cosine is a negative sine t. So this will give us negative 2 sine t as our second derivative. Okay, then we can move on into the third derivative. So we have d3y over dt3. Okay, we have negative 2 as a constant. The derivative of sine is cosine t, so we get negative 2 cosine t like that. And what you're going to find is they're going to have patterns. It's just going to alternate back and forth between cosine and sine, and then you'll have some negatives appearing in there too. Okay? So you could go beyond that. That's a third derivative. Okay? Probably won't ask you ever to do anything beyond a third derivative. Maybe higher order derivatives on easier things in the future like e to the x, or sines and cosines are pretty easy to do. So we're going to do a second derivative on this one. So we're going to start by, have to use the product rule on this. So we have cosine x times cosine x. So when we do the first derivative, we'll just work with the product rule. So we're going to write down the first. We're going to multiply by the derivative of the second. And we do that backwards. Second is cosine x. And then we multiply by the derivative of the first. So you're really doing the same thing twice on this. So we would get cosine x. The derivative of cosine is negative sine x. And then move over here, we'd have cosine x. And again, the derivative of cosine is negative sine x like that. So we're going to get, I'm going to write this as negative 2 sine x, cosine x, because these are like terms. Now, we could use an identity. We're not going to use an identity because we don't know what's called the chain rule yet. So remember that the sine of 2t is just 2 sine t cosine t. So don't change this to sine 2t, because you wouldn't know how to do it until you learn the chain rule, which is what we'll talk about in the future. Okay, so now we're ready to move on. That will give us our first derivative. Now we're ready to use the second derivative, which again is going to be another product rule. Negative 2 is a constant, so I'm just going to write that down. I'm just going to treat the first as negative 2 sine x. Then I'm going to multiply by the derivative of the second. Then I'll do it backwards. I'll do the second. And then I'll multiply that by the derivative of the first. I'm just calling the first negative 2 sine x. Okay, so we'll do that. And then we'll simplify. So we get negative 2 sine x times, and then the derivative of cosine is negative sine x. Okay, like this. Then we have cosine x here, and then the derivative of negative 2 sine x is negative 2 cosine x. Derivative of sine is cosine. Okay, so let's clean this up a little bit. It looks like we have positive 2 sine squared x, and over here it looks like we have minus 2 cosine squared x, like that. So basically there are a couple of things you could do on this with identities. I don't think it's probably necessary. You could factor the 2 out. We don't really have an identity for a sine squared x minus cosine squared x. We do have cosine of 2x is equal to cosine squared x minus sine squared x. So we might be able to utilize that in some way like this. So what we could do is we could do this. We could start by factoring a 2 out of this, and then we would have sine squared x minus cosine squared x. Then we could reverse this. So we'd have negative 2 and then cosine squared x minus sine squared x. Just convince yourself that that's still true. You have negative 2 cosine squared x takes you back here. Negative 2 times negative sine squared x takes you back to positive 2. And then you could write this as negative 2 cosine of 2x. So there's a lot of benefit to taking this down as far as you possibly can. Okay, so those are higher order derivatives. Sometimes higher order derivatives are very simple to do. Sometimes they can get really complex depending on how the function is. Now what you're going to see is, as we move on to the next thing, is there will be a pattern if you look at the higher order derivative of a sine and cosine. So I'm going to go through the first derivative all the way to the sixth derivative on this. So the derivative of sine x is cosine x. We learned that. The derivative of cosine x is negative sine x. We also learned that rule. Now you're going to start seeing a pattern on this. So when we do the derivative of negative sine x, negative is a constant, and then the derivative of sine x is cosine x. So it looks like we're going to have some sort of alternation back and forth between sine and cosine. So now when we do the next one, we'll have negative is a constant. The derivative of cosine is negative sine x. So that takes you back to the sine of x. So notice what's happening. You have a cosine, then a negative cosine. Then you have a negative sine, and then you have a sine. So the pattern is very predictable. You can predict what happens next. Okay, so after we have a sine, we're just starting all over again. The derivative of sine is back to cosine, and then the derivative of cosine is back to negative sine x. So what you're going to find on this is there's a nice pattern that exists with the first 4 derivatives, then it just starts over again. Okay, so you could use that fact to figure out higher order derivatives, like a 100th derivative of a sine x could be reasoned out by looking at this pattern. Okay, so we're going to do some problems. What I want you all to do is there's basically you've got several problems. There's 4 problems I want you to do. We're going to do some higher order derivatives on A and B, and then we're going to do on the next page, you'll do C and D, like this, where you're doing some higher order derivatives, okay? So I'm going to just try to display it like that, best I can, so you can see these. And go ahead and pause the video, and then you can work these out. As soon as you're done, resume and check the answers. Okay, so let me show you what answers I got on this. And again, since you're dealing with trig functions, there may be more than one way that you could write your answer on some of these. So first of all, excuse me, I followed asleep. I'm putting myself to sleep. That's bad. Okay, so we're going to do the third derivative on here. So 2 is a constant, bring it down. Derivative of cosine is negative sine t, and that should have been a t to the third. Derivative of t to the third by power rule is 3t to the second. So you end up getting this as your first derivative. Second derivative, negative 2 is a constant, bring it down. Derivative of sine t is cosine t. Power rule tells us derivative of 3t squared is 6t. So that's our second derivative. Okay, and from here, negative 2 comes down, it's a constant. Derivative of cosine t is negative sine t. Derivative of 6t is 6. That's a linear term. A derivative is a slope of a tangent line. So the slope of a tangent line of the line y equals 6t is 6. Okay, that's how I remember that. So we'd get the final answer would be 2 sine t plus 6. So you don't really have to work with identities in that problem. The next problem, you're told to do the second derivative. So the first derivative is, this derivative of tangent is secant squared x. Now, you all don't know the chain rule yet. I mean, some of these problems would be easier if you knew the chain rule, but we hadn't learned that yet. So to do the second derivative, we're going to have to use the product rule. So we got to write this as secant x times secant x. Then I'm doing a product rule. We got the first derivative of second plus second times derivative of first. So this goes like this. I bring down the secant. Derivative of secant is secant tangent. I do it backwards. Of course, I get the same thing. Derivative of secant x is secant x tangent x. Then when you put this together, notice on here you'll have secant squared tangent plus secant squared tangent. And those are like terms, so you just have 2 of those. And I'd be okay if you stop there. Okay, that's fine right there. That's a factored form. I don't think you'd probably need to go any further with that. You could use this identity that the secant squared x is 1 plus tangent squared x. So you could do this substitution. You could substitute that for that. That would also be a good answer. Then you could distribute it out if you wanted to, but I don't think that's really necessary. I'm okay if you get to this point right here. Okay, now moving to the next page. If you need to pause, go ahead and pause, but I'm going to move to the next page. Okay, so what you should have got on this one, part C would be so much easier if we knew the chain rule, but we don't know it yet. So if you go as far as I'd really like you to go, you would either get negative 4 sine t cosine t, but that can be simplified with an identity to get negative 2 sine 2t, and that's beneficial for things we learn later to take it all the way to that endpoint. Okay, so what I'm doing on this is I'm just doing a product rule. So I've got first derivative of second plus second times derivative of first. So it goes like this. Notice the derivative of cosine is negative sine t. Derivative of sine t is cosine t. Then if you follow through this, I've got negative sine t squared plus cosine squared t. I can change that around, and what I would have on this is this identity is cosine 2t. The problem is you all don't know how to do a derivative of cosine 2t yet because you don't know the chain rule. So in this stage, you're best off to just leave it there. So I'm going to rewrite this as cosine times cosine minus sine times sine. Then I'm going to use the product rule on each one of these. Okay, so first cosine, derivative of second, second derivative of first when I do the derivative of cosine times cosine. And then I got to do the product rule over here. I got first derivative of second plus second times derivative of first. So when you do that product rule twice, these are like terms. That's negative 2 sine t cosine t. And then this right here, this whole thing right here becomes negative 2 sine t cosine t. Okay? So these are like terms, see? So you can put that together to get negative 4 sine t cosine t, which is fine if you get that answer. But if you're clever, you could write this as negative 2 times 2 sine t cosine t. The reason I'm doing that is because we have the identity that the sine of 2t is 2 sine t cosine t. So then I just change the 2 sine t cosine t to sine 2t, and then just bring that negative 2 down. So when you learn the chain rule, it'll be real easy to go from this point to that point in your head. Okay, I'll go ahead and show you how to do that right now, just so that you know. If you do the derivative of cosine 2t, we know the derivative of a cosine is a negative sine, but that is a different function. So what you do on the chain rule is you multiply by the derivative of what's inside, so you get negative 2 sine 2t. Okay, if you don't catch that now, that's okay. We learn that in the next section. Okay, so that's as far as this video will go. I'm going to record a 5th part where we just do a couple of applications. All right, so hopefully this works well for you and you understand this well. The hardest part to me in this entire section for most students is working with trig identities. Okay, in a trig class, you learn how to prove identities. Part of the purpose of that is to get you good with taking an expression and rewriting it in a different form with trig functions then. Okay, so that'll wrap this part of the video up. Good luck. Hope you enjoyed it.